talk about polar coordinate. If you continue on to calculus 3, you're going to encounter this again. And hopefully at that time, you're going to still remember this, okay? So 10.3 polar coordinate. And how does it work? In the past, we have this rectangular coordinate, right? So you have this x and y axis. We have an order pair to represent the position of this point. Now in polar coordinate, now this origin over here is going to be called the pole. That's the pole. And we're going to have this axis that used to be this positive x-axis. Now we're going to call this the polar axis. This is the polar axis. So it consists of two things. Okay, it consists of the pole over here and then also the polar axis.
Whoa! Wow!
Now, to find the location of a point on the plane, you have two coordinates. The first coordinate r is going to be, well, if the data is going this way, then this r here, think about it as a distance from here to the pole. So how far is this one? So this is the r. And then this data over here is the angle that this ray over here form with this polar axis. That's the data. As long as you know this two pieces of information, you're able to locate this point. Now, for example, like this point over here. Here, from here to here, the distance is 1. Now, this is the polar axis. The angle that this ray over here, okay, we call it the ray, okay? So ray here is this is a ray. Okay? It's a ray that from the pole point to this point, this is a ray. The angle that formed by this ray and this polar axis is this theta. Because it goes clockwise, so it's negative. So negative 3 pi over, okay, negative 3 pi over 4 right here. Okay. Then in polar coordinate, this point here is represented by the first coordinate here will be 1. Okay. The second coordinate is negative 3 pi over 4. That's the coordinate of this point in polar coordinate. Now let's look at another point. For example, this one over here. Okay, well, this time let's reverse it. Okay, this time I'm going to give you the polar coordinate over here. Let's try to locate the point. So this one here, r here is -2. Can you have a -2 for r? It is possible. Okay, you can still have a negative number for r. Okay, but how does it work? The way that it works is this. So this angle here is, this is the data, right? Data is power 4. So what do we do over here is we have this positive polar axis right here. And then because this one here, it is positive, so we're going to go counterclockwise. So go counterclockwise this way. And then we will draw a ray going this way, pointing in this direction. Okay, so that will be the ray pointing this way. So think about this way. So draw a ray pointing this way. Okay. Now, when the r here is negative, instead of go along the direction of this ray, we're going to go to the opposite direction. So instead of pointing this way, you go the other way. So you go the other way, and then you locate 2. So 2 distance away from this. Okay, from here to here will be 2. And then you locate this point. Then this point over here is the point that corresponding to this polar coordinates. You see it? So when this r here is negative, you just go the opposite direction of this ray. Okay? Now you see that it's actually not unique. The polar coordinate is not like Cartesian coordinate. It can have different representation for the same point. For example, for this point here, if I want the R here to be positive 2, what angle data I can put over here? Well, you can go this way, right? You can let the ray point this way, and then you will go 2 units away from the pole. And then you can think about what will be that angle, right? What's this angle? 5 pi over 4. Yes, you got it. Okay. So that you can put 5 pi over 4 here. Because if you go 5 pi over 4 counterclockwise, and the ray is going to point this way, right? And then you just go along the direction of the ray and 2 units away from the pole, and that will be this. Okay, so this 2
Can I ask a question?
Sure. Yeah.
So it's negative because of going counterclockwise and not because
This one, the negative.
Yeah, I guess in general, like, can you say again what the difference between negative and positive
Okay.
is?
Okay, very good.
I understood that.
I'm glad that you asked. So suppose the ray point this way, right? Okay, and then this is the data. Okay, this is the data right here. Then if the R here is positive, then it's going to go along the direction of the ray, if it's positive. If the R is negative, then you're going to go the other way, the opposite way. When the R here is negative, you go the opposite direction of this ray right here. Okay, see.
Okay, so then I guess because the second one is a positive 2, then you start above, and then because 5 pi over 4 is positive, you're going counterclockwise.
Yes. Okay. Yes. Let me maybe put it in a separate coordinate, right, system here. So I have this polar axis. Here is a pole. Now this is 5 pi over 4. So starting from the polar axis, I'm going to go counterclockwise 5 pi over 4, which is going to be end up over here. So 5 pi over 4. And then the ray is going to point this way. Okay. So data equal to 5 pi over 4. Okay. The ray point this way. That will be the point. Okay. Now because and then the R here is positive, then you just go along the direction of the ray, and then just make 2 units away from the pole. So that's why you have this 2 over here. Okay, so from here to here, that's 2, and you get this. Okay. Okay, so just remember, if R is positive, you go along the direction of the ray. If R is negative, you just go opposite direction of the ray. Okay. Okay, you first locate the data first. Okay, so you first locate data and you draw the ray, and then you will, depends on what this R is, you will get positive will be here, negative will be here. Okay, can you also think about another representation of the same point here? So instead of 5 pi over 4, if you measure the angle this way, what angle would that be? This one. When you go clockwise over here. Negative 3 pi over 4, right? Yeah. So when it's clockwise, the angle here you would say is negative. So it's negative 3 pi over 4. When the data equal negative 3 pi over 4, the ray also pointed this way. And it's positive 2, so you go along the direction of the ray, measure 2, and you locate that point right here. And there are many, many different representation of the same point, because if you add any multiple 2 pi, you're going to end up at the same point anyway. Any multiple 2 pi to the data, you're going to end up at the same point, right? Okay. So you see all you have here, you see there are many different representation of the same point. So polar coordinate is not unique. Okay, you can have different representation. Yeah. Oh, so Alejandro has a question. Say, what happens if this is negative and this is negative, right? Okay, suppose you're given this. So let me do this. Say if you have -2 comma -3 pi over 4, then how do you draw it? Okay, then oh 5 pi over 4? You want 5 pi over 4? Okay, sure. Same thing. So suppose this one here is 2 5 pi over 4. How do you draw this one? Okay, so this is a separate point. Then the way we do it here is this. So you draw the polar axis first. Okay, here's a pole, label that with O. And then we'll first get the angle here first. Angle is 5 pi over 4. So it's going to rotate and then go counterclockwise. So it's 5 pi over 4. Theta equal 5 pi over 4. You see the ray here? It point this way. Okay, we end it here. Now, the R over here is negative. It's negative. So instead of go along the direction of this ray, which way I should go? You go the opposite. Okay, so you go the other way. So you go this way. Okay, opposite this. And then you measure 2. Measure 2 units away from the pole. And then the point will be this. So this will be the point right there. Okay. So just remember, when the R is positive, you go along the direction of the ray. When R is negative, you go the opposite direction of the ray. Right? Just, Alejandro? Okay, good. Okay, now we're going to convert. Okay, let's convert from polar coordinate to Cartesian coordinate. How do we do this? So we start with this. Let's look at this diagram. Okay, this is a pole and this is a polar axis, and this is R and this is theta. Now for this point over here, if I want to write the x and the y coordinate, so this will be x and this will be y, right? Okay. How do they relate? X, how can I represent x here using R and theta? R times cosine theta, right? Yeah, very good. Okay. Now remember, R over x is cosine theta, right? R over x is equal to cosine theta. Okay. So x, I'm sorry. Okay, just checking. Do you guys see the mistake? Is x over r is cosine theta. X over r is cosine theta. Scratch that. Okay. So x is equal to r cosine theta. In the future, just remember, if it's an adjacent side over here, then it's this r times cosine theta, right? Similarly, y over r is what? R sine, oh yeah, y over r is sine theta. So therefore, y is equal to r times sine theta. So this one here is actually good to remember, okay? This adjacent side here is r times cosine theta. This opposite side with this angle is r times sine theta, okay? So when you convert polar to Cartesian, you're going to use these two equations to convert. Okay, so remember this one. Let's try to do some example. So here is 2. This is pi over 3. And remember, this one here is in polar. This is a polar coordinate. And we want to think about what will be the Cartesian. Cartesian. I think I spelled this right. Okay, let me see if I can convert. Cartesian. Okay, good. So that's a Cartesian coordinate. Right. So how do we find the x? X equal to what? Yeah, r cosine theta, right? R cosine theta. So R here it is 2. Theta here is pi over 3. What's cosine pi over 3? 1/2. Yes, very good. So you have 2 times 1/2, which is 1. So the x coordinate will be 1, right? Okay, good. Can you find the y coordinate? So that is r sine theta. So y should be 2 times sine pi over 3. What's sine pi over 3? You got it. Good job. Okay. So this will be square root of 3. So you put it over here. So in Cartesian coordinate, this point will be the same point as this one. Okay. So the polar coordinate at this point will be this. Then in Cartesian coordinate will be this. Okay. So keep that in mind when you try to convert polar to Cartesian. You use these two formula, right? These two equations. Now, what about we go back? Suppose you have this Cartesian coordinate, and then you're trying to convert into polar coordinate. Then what do we use? Okay, let's try to think about how can I represent the r and theta in terms of this x and y, right? Let's think about that in this right triangle. This is a right triangle, so it's going to satisfy the Pythagorean theorem. So how is this r here related to x and y? X squared plus y squared. Good job, okay? So that will be x squared plus y squared equal to r squared. So if you figure this r squared, then you can figure out the r later on, right? Okay. And then you also can try to think about the data. For the data, because we know the y and the x, then this is the opposite, this is adjacent. So what's y? What's tangent of data? Y over x, yes. Okay, so that is y over x. And after you do this, you can figure out data by taking what? The inverse tangent to figure out what this data here is, right? And then also depends on which region, which quadrant that the point is, then you can figure out what the data, okay? So let's try some example. Over here we have a Cartesian coordinate for a point. We try to find the polar coordinate of that point, okay? Let's try to figure out the r. R squared is equal to what? Equal to 2, right? Yeah, you got it. So 1 squared plus -1 squared, which is equal to 2. So what does R equal to? Which one you want? You can have positive square root of 2, right? Okay, positive square root of 2, okay? You can also make it negative, but then the data will be different. So let's just keep it simple, positive square root of 2. Then let's try to figure out data. Tangent data equal to what? -1 over 1, which is -1. And then what would this data here in equal to? So if you take inward tangent of -1, what angle you get? Pi over 4, right? So remember, if you take inward tangent of -1, you will get pi over 4. Okay, so you should get pi over 4. But then this is not the angle that we have. It depends on the quadrant, okay? The quadrant, which quadrant it is, okay? So to figure out this data, you will think about which quadrant this point is located. So 1, -1 is right here, okay? It's right, actually, sorry, right here. 1, -1. It's at the 4th quadrant, okay? So that's at the 4th quadrant. And then you figure this one. Oh, I'm sorry. It's not pi over 4. What is it? Remember, inward tangent can only go from negative power 2 to power 2, remember? So that it should be what? Negative pi over 4, negative pi over 4, okay? So over here, you have data here to be negative pi over 4 if you go this way, okay? Then we're going to do this. Then we can pick one of the representation. So if I use this data over here to be negative pi over 4, so let's write it down. So negative pi over 4 over here, then what will be the R here? Square root of 2. Yes, you got it. Square root of 2. It go along the direction of this. So square root of 2 right here, right? What will be another representation of this same point over here? Yes, very good. So if I still keep positive square root of 2, for this one over here, if you go along this way, right? If you go along this way, then you can also have the angle like this, right? We go like this. I still end up with the same ray over here. So instead of negative pi over 4, we can also let data to be what? 7 pi over 4, right? Yeah, you got it. So you can have 7 pi over 4. You still get the same point over here. Okay. All right. Well, this is just having a taste of this polar coordinate. Okay. I think I catch up real fast. Okay. Okay. Now I'm going to talk about polar equation. This is an example of a polar equation. Remember, for Cartesian, right? You will have an equation relate x and y. Now we have an equation that we relate r and theta. Okay. Remember, we have r and theta. So we have an equation relate r and theta. So here, r here is a function of theta. Okay. In this one here given is r is equal to 2. We want to see what polar curve this is going to look like. So in polar coordinate, what will be the curve? What does r equal to here mean? R is you can think about as the distance of the point to the pole, right? It is equal to 2 all the time. And does it have a restriction on data? Does it mention about data? No, data could be any, right? Data could be any angle. But as long as r is equal to 2, then it will be on the curve, right? So the distance from the point to the pole is always 2. What kind of curve you think we're going to get? It's going to be a circle. Yeah, you got it. Okay. So that will be a circle. Let me see if I can draw a perfect circle here. See? I draw a perfect circle here. The r here is equal to 2. So all those points here will have r equal to 2, and data could be any number. Okay. So the polar curve here, if I want to write it in word, is the circle with center O, which is the pole, and then radius to be 2. Okay, so that's the polar curve for this polar equation. Data equal pi over 4. And we're trying to graph this. So this one doesn't mention about R, right? R could be any number. But as long as data is equal to pi over 4, we are okay. Okay. So first we will draw the ray. So this angle is pi over 4. So from the polar axis, we go counterclockwise and we locate pi over 4. And then we draw the ray like this, right? And when R is positive, you get this part of the ray, right? Pointed this way. When R is negative, we get what? The other, right? Right here. Okay. So when R here is all real number, when R here could be all real number, you get the whole straight line over here, right? Okay, so you get the whole thing right here. So the polar curve here will be this straight line that passing the pole and with this angle here to be power 4, this whole line. So including this and the pole and then this, okay, this whole thing. Okay, the next one over here is going to be this polar equation, R equal 2 cosine theta. Well, how about we try to fill this out for a little while? So let's try to pick different data here and just try to get a feel of how those points look like, right? So say data to be 0, what's cosine of 0? 1, then 2 times 1 will be 2, so you got 2. Okay, good job, okay. Okay, pi over 6. Try. Yeah, 0 2, and then you multiply by 2, what do you get? Yeah, you got it. Good job. Okay. Next one, square root 2. You got it. Okay. Next one, 1. Oh, good job. Okay. All right. The rest here, I fill this out for you. Okay. Now, what happened here? I'm going to plug in those points. Okay. How do I do that? Remember, this one here is the angle data, right? When data is 0, it's going to be this way over here, right? Just the polar axis like this. Okay, and along this polar axis, I'm going to locate 2 units away from the pole, so I get this point. So I get this point over here. So this is this point right here. Okay, the second one, I will locate this. So data is power 6, and then R is root 3. I locate this point over here. Okay, and then the next one continue this way. So I kind of run out of color. So this one over here is this one over here, and then you get the idea. So I continue this way, I get this one, and then I got pi over 2. Okay, now this one over here, it is pi over 2 and 0. Okay, how do we do this? So you have this ray over here, theta equal pi over 2, pointing up, but then R is 0. When R is 0, then you're going to just stay at the pole over here. You're not going to move away from it when R is equal to 0. So that one here, it is going to be this one over here. And now what happened here when this is negative? How do you do this? What happened when R is negative? You go opposite direction of the ray, right? Let me see if I can find different color. So I'm going to go this way. This one over here. So it is 2 pi over 3. So it is 2 pi over 3 right here. Data equal to 2 pi over 3. So instead of going this direction of the ray, you go the opposite. So instead of going this way, you go the opposite way here. And you're going to locate negative 1. So you're going to end up over here. Okay, so it is this one over here. This one over here. Okay, so you go the opposite direction of this ray. You will go this way and you go 1. So you get this one over here. And similarly, you get to all those other points. And looking at this, what does it look like to you? It looks like a circle, isn't it? Okay, so it looks like a circle, but how can I be sure this is a circle? This is a circle. Okay, it looks like a circle with center over here with radius 1, right? And I can actually prove that this is actually a circle by doing some, I can change this polar equation into a Cartesian equation and see does it fit into equation of a circle.
Okay, I found this on the web for and she does it fit into equation of a circle. Check it out.
I like this. Thanks, Siri. She didn't say you're welcome. Okay.
It never does.
Really? Okay. I like Alexa better. Siri, right? I like Alexa better. Okay. Okay, so This one here, it is polar equation. I'm going to change that into Cartesian equation, see if it's a circle. How do I do this? Okay, let's see how do I do this. Let's write this one down here. Okay. So I have this R is equal to 2 cosine theta. Okay. I'm trying to make use of, remember the 4 equation that when I convert back and forth, I use this 4 equation. So I put a star here means those are the ones that you probably, it's good to remember, and it's for now for you to change back and forth between polar and Cartesian, okay? So I have this equation. I want to make this equation into X and Y. And then looking at this, what should I do? I noticed that this one has a cosine theta. If I have a R times cosine theta, that would turn into what? An X, right? So how about we multiply both sides by R? Can we do that? So we're going to times both sides by R. So multiply both sides here by R. Then what do I get? I will get R squared equal to 2R cosine theta, right? Okay. So the trick here is try to do something with the equation so that you can make use of this to convert into X and Y. So it has cosine theta. I want to have R cosine theta. So that I can make use of that to convert R cosine theta into X, right? Okay. And I also noticed that what happened to R squared? What does R squared equal to? X squared plus Y squared, right? Okay, good. So that will convert into X squared plus Y squared. And this is 2 times what? X, right? That is turned into X. So they all turn into X. Now let's see if I can relate this make it into the standard form of a circle, right? So remember how I actually do it down here. So then as a quick review for you, how to complete the square to make it into standard equation of a circle. The way that we do it is this. So you put the X term together and you need some space here for a number and you put the Y terms over here, okay? And then here equal to whatever here. So X squared minus 2X, what number do you add here to make a perfect square? 1, yeah, you got it. So I will put a 1 there, right? So I will put a 1 here. So that will be a perfect square. If I add a 1 on this side equation, I need to add 1 on the other side to balance it, right? Okay, so add 1 to both sides. Now, this 3 turn here turn into a perfect, someone say, how do you know that's 1? If the leading coefficient of this is 1, so X squared, then you can take half the coefficient of this. Half of that is -1. And then you square and then put it here. Okay. So for example, if you have, say, suppose you have something like X squared minus 6X, and you try to figure out what number to put here to make a perfect square, you do it this way. So since it starts with X squared, so you take half of this, half of -6 is -3, and then you square this. Square of -3 is what? 9. So when you add a 9 over there, then this 3 turn here become a perfect square. What perfect square is that? X minus 3 perfect square. So to complete the square, when the leading coefficient is 1, we do it this way. So that was the trick in algebra. Okay, so I was using the trick. I make this into a perfect square. It is X minus 1 perfect square. Okay, and this is a Y square. It's all the perfect square. And this one here, on this side here, we have a 1. Just remember, if you add a number on this side, you need to add a number on the other side. So you add 1 to both sides. Okay. Now, this is going to be the standard equation of the circle. Okay, remember we talked about standard equation of circle, right? So that was x minus h square plus y minus k square equal to r square, right? So that's the standard equation for a circle. So this one here is in the standard equation form. From here, you can tell the center. What's the center? 1, 0. Yeah, the center is 1, 0. Okay, good. So the center, okay. And what's the radius? 1, yes. Radius is 1, okay. So indeed, it is a circle, right? So by convert this polar equation into that, we know it's a circle. But someone said, that's a lot of work. Now I'm going to tell you a trick. You can tell that right away. Oh, I'll actually explain over here, okay? You can tell right away is this a circle or not, okay? In polar coordinate. This one over here, whenever you have an r equal to a number times cosine theta or sine theta, it's going to be a circle. If it's the number times cosine theta, then will be a circle that is going to be that's going to pass the pole here, and the circle will be this way. So it's going to be a circle going to the center is going to be on the polar axis over here, and the radius here is then what would this 2 here? The 2 here correspond to the diameter of the circle. Okay. So that's the diameter. That's the diameter of the circle from here to here. Okay. And when this is a number times sine theta, you're going to get also a circle, but this time the circle is going to be this way. Okay, one more time. Hey, yes. With this. Okay, better. Okay. All right, so this time the center is going to locate it at this rate that with theta equal pi over 2. Okay, so over here. And you see the center is going to be over here. Again, the 3 here is the diameter. From here to here, this is the diameter. That's the 3. Okay. You can actually use geometry to justify this. Okay. Remember when you have a circle, then this angle that formed by a point on the circle with this diameter, then this is going to be a right angle, right? So this is a right triangle. This is 2 times cosine theta. What's 2 times cosine theta? 2 times cosine theta. Does it give you the distance from here to here? This one? Okay. This r over here, right? This r over here is going to be 2 times cosine theta, right? Okay. Yeah. So it justifies that. Okay. And then similar reason for this. This r here times sine theta will give you this r over here, right? The r over here is going to be 3 times sine theta. So this r. Okay. So next time you see a number times cosine theta or a number times sine theta, you notice that will be circle. Okay, as one of these cases. Okay. So you don't have to do the complete square again and again. You can recognize it right away. Okay. Are you guys okay? Okay, good. Next one here, we're going to sketch the polar curve. This one. Okay, let's just do that once in your life, and then later on you don't need to. Okay, just do it once. Okay, so sketch this. Okay, the book will do this way. First, we want to sketch this in Cartesian coordinate. So we're going to have the data here and the r over here. This is r. Okay, this is data. Okay, so how does the graph look like? We know how the sine graph look like, right? Sine graph look like it's the sine curve. Remember, right? Sine. You gotta remember the sine curve, right? So that was like this way. Like, however, okay. So therefore sine. But then here you add 1 to it, it's gonna move this up 1 unit, right? So you move up 1 unit, so it will be here. This is 1, and you go this, back, then this. So that's the sine. This is 1 period of this, okay? So it's going like this. Now after this, you can use this to draw this in polar coordinate. This is only in Cartesian coordinate. How do we do this? Well, let's divide that into separate interval, okay? Let's think about from 0 to power 2. From 0 to power 2, what happened to r? R starts from what? 1. So it is 1. And then it's going to go up, right? Isn't it go up, right? Go up to what? 2. Yeah, that was 2. So here, that's 2. So 1 go up to 2. Okay. Now, what about from power 2 to pi? From 2, go up or go down? Down to 1. Yes, you got it. 2 go down to 1. Okay. Okay. What about this? From 1 go down to 0, right? Yeah. So 1 go down to 0. And then here will be 0 go up to 1. So 0 go up to 1, right? Okay. So here's the idea. So we're going to try to plug in some point, right? So 0 to power 2. Okay, let's think about this. This is data equals 0. This is data equal power 2. And what happened to the r? The r is going to increase from 1 to 2. When it is 1, but data equals 0 is 1, it's going to be this point, right? So when it's 1, it's going to be this point over here. Okay. And what happens if you increase the data to power 2? The r also increase. So you have 1 over here. Let's draw this. So this is the 1. Okay. And as you increase the data, then the r also increase. And then finally get to this point, r equal to 2, and data is power 2. So you get here. So it gradually increase like this. So here's the graph right here. Okay, like this. And then similarly, you can get other like this. And then from here, you can draw the other one. And then here, draw the other one. And when you put together, what kind of shape does it remind you? It's just like a heart, right? In the past, I actually test students. I only give you heart or what's that? Flower. Okay, this one over here, it is a heart. Okay, heart right here. Okay, the name for this is called cardioid. Okay, you know, can you guys spell cardioid to me? Oh, ID. Yes, yeah, you got it. Good job.
Can I get a
Good try. Good try. Okay, maybe next time. Okay. Okay, cardioid. Okay, so this is the shape of it's like in a heart shape. Okay, so it's called cardioid. Okay. Okay, so this is how it look like. Okay. It seems like a lot of work, and you graph this by hand. Later I'm going to tell you a trick. You can actually graph this using decimal. This decimal, you've entered the polar coordinate, and they can also graph it to you. But at least we understand how this come from, right? So you get this, what happened to R? R increase like this. Okay, you graph this. Okay, so cardioid. Now, when you graph this, it can actually make you some symmetry. This one over here, it has some symmetry, right? Isn't that symmetric with respect to this line right here, right? Okay, so let's think about them. If you know the symmetry, you can draw maybe the right half of the curve, and then you can get the other half by think about this like a mirror to draw the other half, right? Okay, so symmetry is going to cut your work in half, or sometimes maybe in a quarter. Okay, so let's think about what kind of symmetry. Okay, and how can you tell the symmetry? Okay, so suppose you have a point here, r comma theta, and then the other point r comma negative theta is also on the curve. So if you replace the data here by negative data, both of them are on the curve. So both of them satisfy the equation. Okay, so if you replace data by negative data, you get the same equation. Then what kind of symmetry you think you're going to get? Symmetry with respect to what? Yeah, polar axis. Wow, you can catch up very fast. Someone you say x-axis, but since we talk about polar, so we call that polar axis. Okay. Okay, good. Okay, very good. Okay, now if you replace the r here by negative r, and you get the same equation. Okay, so that means if we replace this r by negative r, this point also on the curve. So these 2 points are symmetric with respect to what? With respect to the pole, right? The pole right here. Okay. Yes, symmetric with respect to this pole. Okay. The pole. Okay, so that's gonna work. Okay, number 3. If the equation is is unchanged when data is replaced by pi minus theta. So let me make it larger. So here it is theta. This is pi minus theta. So if you replace the data here by pi minus theta, both of them satisfy the equation. Okay, you get the same equation. Then think about this 2 points. What kind of symmetry you have? Symmetric with respect to what? You could say y-axis in Cartesian coordinate. However, in polar coordinate, what's the equation for this y-axis? Theta equal to power 2. Yes, you got it. So for that one, this one over here, in polar coordinate is theta equal to power 2. So symmetric with respect to theta equal power 2, this line. Okay, the line. Okay, all right. All right, so welcome back, everyone. So now we're going to talk about tangents to polar curve. Well, first of all, do you guys remember how we find, when we find tangent line, we need to find the slope, right? So what's the slope of the tangent line correspond to? Slope is what? Slope of tangent is, yeah, it's the derivative. It's dy dx, right? Okay, slope of the tangent should be dy dx. So our tangent is dy dx. But why now we're not using x and y, we're using r and theta, right? Okay, so now we have r and theta. Okay, then we need to somehow relate this. We need to get y and x, but we do know how we change from r theta to xy, right? And what do we use at that time? X is equal to what? R cosine data. Yes, R cosine data. Y is equal to R sine data. Yeah, you got it. Okay. Okay, so this. Now, by doing this, if I had this, that looks like remember last time we talked about parametric equations, right? That looks like the parametric equation. And by this, we are able to figure out what this dy dx is, right? So how do we figure this out? Do you guys remember? Dy dx is dy d something dx d something dt, but this time is what? D data, yeah? Yeah, dy d data. So let's try this. So the data here and the data here. So it's d data and then d data over here, right? So then we can figure out the slope by using dy d data divided by dx d data, okay, from this equation. This should think about that like the parametric equation that we have last time, okay? So that's the idea, okay? So let's try to figure out, so this is what the formula here is. Dy dx is dy d data over dx d data, exactly what we have here. But now let's try to figure out what dy d data equal to. What do you think? From here, now remember that R here is also changing. R here is not a constant, okay? So what is this? What kind of rule do we need to use in order to find, okay, let's do it over here, okay? So let's do this, okay, from this, too small. Okay, from this, let's try to find dy d data. What kind of rule do I need to use in order to differentiate this with respect to data? It's a product rule, right? This is a product, right? It is this multiplied with is this one times this one, right? All here is a function of data, and then this is also a function of data. So we use the product rule. Okay, let me put that up. So we have to use the product rule to differentiate. According to the product rule, we're going to differentiate I would like to differentiate the first function first. So that will be dr d data, right? Dr d data. Okay, that's the derivative of the first function with respect to data. We'll differentiate that with respect to data. So we take the first function, differentiate with respect to data. So that's dr d data. And then we're going to multiply that by the second function, which is sine data. Okay, after that, we're going to add, right? Add. Now we're going to keep this function here, the first function unchanged. So we're going to have the r over here. And then now we're going to differentiate this function, sine data, with respect to data. What's the derivative of sine data with respect to data? Cosine data. Yes, you got it. So that will be cosine data. So this is exactly what we have here. Let me just copy this. And I should put it over here. So that will be the numerator there. Okay, that's dy d data. Well, since you're doing so well, how about we do the dxd data here in the denominator? Again, we're going to use the product rule, right? So tell me, what should I put here? dr what? Wait. DRD data. Differentiate this with respect to data. So DRD data, right? So let's write down. So D data. Okay, multiply with the second function, which is cosine data. And then adding. Now we're going to keep the first function unchanged. Just keep that, just R. And then we're going to differentiate cosine data with respect to data. What do we get? Negative sine data. So I'm going to change the sign here. Okay, so that is minus. So that is minus, and minus sine theta, right? Okay, so this will be the formula. So now someone will say, how can I remember this formula? You don't need to remember. Remember, I don't recommend you try to memorize it. I will just ask you to just remember this. X equal this, Y equal this. And then when you do that, you can just go ahead and use the product rule here and product rule here. Okay? So that's the formula. Okay, now how do we use it? Well, this is going to be useful. Remember last time we talked about horizontal and vertical tangent. When do we get horizontal tangent? Horizontal tangent, the slope will be equal to what? Remember this represents slope, okay? So this is the slope of the tangent. Okay. So when you have horizontal tangent, the slope equal to what? 0, which means the numerator equals 0 and the denominator does not equal 0, right? What happens when the denominator equals 0, but the numerator does not equal 0? You have 0 under, then what do you get? You get vertical tangent. Yes, you got it. So this is exactly what happened. Okay. All right. So now let's do the next example. Can I ask someone to read this? Okay, good job. Okay, thank you. Okay, so we're trying to find the slope of the tangent. Remember this one here is the slope of the tangent. Here they just put the formula down there and then you can just go ahead and plug in, right? It's kind of small. Okay, let's see. Wow, Emily has good eyesight. So, okay, let's dr d theta. What's dr d theta? R equal this. What's dr d theta? Cosine theta. Yes, you got it. Because the derivative of a constant is equal to 0. The derivative of sine theta is cosine theta, right? So that should be cosine theta. Okay, let me write down. So dr d theta here will be cosine theta. Okay, and then now times sine theta as r times the r here we're going to replace, right? We're going to replace the r here by the r over here is, yeah, it's 1 plus sine theta and then cosine theta. Okay, and then dr d theta we already got, which is cosine theta minus r is sine theta. All right, let's simplify this. Can we take out this common factor cosine theta? Right? Okay, wait, let's take that out. So we have cosine theta. And then we have sine theta plus 1 plus sine theta. So that is what? 1 plus how many sine theta? 2 of them. Okay. So down here, what would you like to do? Well, this is cosine square, right? And then minus sine theta minus sine square. Let's just keep it like that first. Let's see what happens. What would you like to do here? For the denominator, let's see what do we do. How about we convert that all into sine theta? Looks like this is sine theta. Can I replace the cosine square here by something with sine square? This is what? 1 minus sine square, right? Okay. That's 1 minus sine square. So let's see what do we have here. So this whole thing over here is going to turn into, what does it turn into, you think? So it is, okay, let's put that from the highest power to lowest power, okay? So negative 2 sine square theta, right? And then minus sine theta, right? And then plus 1, right? Do you agree? Okay, now this one here, does it remind you of the quadratic equation? This one here is the square of this, and then the last one here is number, right? So if I can kind of remind you of the quadratic, this is kind of like the x square, right? And this is like the x, right? So do we know how to factor negative 2x squared minus x plus 1? How do we factor this? You can try, well, you can try to take out the negative sign, negative 2x squared plus x minus 1, and then you can try to factor, right? Okay, let me go for the Chinese trick to you guys how to factor this. So the way to do it is, here's 2, then we can try 1 times 2. And here's negative 1. I'm going to try 1 times negative 1 that way to make negative 1. Okay, this one. And then my cos multiply and add. So this 2 cos multiply is negative 1. This 2 cos multiply is 2. What's negative 1 times 2? I'm sorry, plus 2. Sum this up. It's 1, which is equal to the coefficient of this x here, which is 1, right? And then I know that I got the right combination. And then I can write down the factoring. So how does the factoring work? So at this time, you're going to put back the x, okay? So you will have this x and x back. And you read this horizontally. So this is x plus 1. And then the other one is 2x minus 1, like that. So that's how I do the factoring for this, okay? Okay, now when we do this, because later on we try to figure out when the denominator equals 0, so it's better that I put this in a factor form. So I will put this in vector form according to this, and think about this sin data is the same as this x. What should I put over here then? Negative. I heard you say something. Okay, say that louder. Like, replace this x here by what? Sin data. So that will be sin data adding 1. Okay, that 1. And then the other one is 2 sin data, that 1. Looks like the trigonometry come back to you. A lot of trigonometry to do in calculus, okay? Right, like this, okay, good. All right, so you did the factoring, which is very, those are the challenge part, right? So this one over here is basically correspond to this, okay? That one. So I put it that way, okay? Okay, the numerator, I'm going to just leave it like that because it's already factor. Because I'm going to just copy, okay, like that. Okay, now we're in business. Now we're going to see when the numerator and denominator equals 0, okay? Oh, that was for the second part. This is actually getting ready for the second part. Okay, but so let's just leave it like this. The first part over here, part A, they just want to find the slope of the tangent when data is power 3. You already found the slope of the tangent, right? This is the slope of the tangent, okay? Remember, this is the slope of the tangent. That is it, okay? So now data equal power 3, what do we need to do? Just plug it in, right? So we're going to plug in data equal power 3 into this dy dx right here, and you got this. Okay, I know that it's kind of messy, but let me tell you at the end, you should get -1. Okay, okay, you fill in the blank when you go home, okay? Okay. Now, so we finished the first part. The second part here is we try to find the point on this cardioid that the tangent line is horizontal or vertical. Okay, so we're going to focus on the numerator and the denominator. Okay, let's look at the numerator. the numerator equal to 0, right? This is odd factor. Remember the 0 factor property? The only way to make 0 is either this one equals 0 or this one equals 0. One of them has to be 0 to make the product be 0, right? It's like something happened in the room, there's only two people. Either he did it or he did it, okay? So you did it or you did it, okay? Okay, so when this equal to 0, when cosine data equals 0, what data will be? This is the trigonometry. Power 2? Okay, good. You got it. More than that. 3 pi over 2? Wow, you got good at trigonometry. Pi over 2, and then also 3 pi over 2. Okay. So those are the two angles, right, in radian that cosine that equal to 0. From 0 to 2 pi, we have this two, okay? We only consider from 0 to 2 pi now. Okay, because the graph is going to repeat every 2 pi, so I only care about from 0 to 2 pi, okay? And then what about for this equal to 0? For this equal to 0, let's think about sine data is equal to what? Negative 1/2, right? From this, okay? So let's think about from 0 to 2 pi, what data is equal to. Now I will see who's the teacher. Power 6, that would not be, you're almost there. Except remember here it is a negative. Yeah, negative. It's negative. Oh. Yeah, I'm trying to find the data. Sine data equal negative 1/2. 7 pi over 6. Okay, so 7 pi over 6. Okay, one more. 11 pi over 6. Okay, now I know that is good. Okay. All right, so you got those angle, right? Okay. Now this one over here, okay, the denominator equal to 0. Now here you can actually distribute the minus sign in here. So opposite of this is 1 minus sine data, which is the same as this one, okay? Now this one equal to 0 is when this equal to 0 or this equal to 0. But that equal to 0, this is sine data equal to negative 1. And here is sine data equal to 1/2. Again, trigonometry. So the first one, wait, hold on. This one, negative 1. 3 pi over 2. Okay, good. 3 pi over 2. Okay. Okay, and then this one? Yeah, you got it. Pi over 6. Okay, and then next one? 5 pi over 6. Okay, 5 pi over 6. Good. Okay. So, wow, you guys did a good job on this. You found all of them. So now you got those data, but we're interested in the point, right? So the point, we got the data, but in polar coordinate, we need the data and we also need the R, right? So you need those points. So how can I find those points? So you already get the data already. We just need to figure out this R, right? So how do you find this R then, if you know data? What does it say here? R equal to this, right? Okay, let me copy this. Okay, R equal to this. Okay, so R is equal 1 plus sine data, and then you can just go ahead and plug in the data here, and then you can figure out the R, right? Let me put the angle here, pi over 2 first, okay? The data here is the first one here is pi over 2. Can you guys figure out what R equal to when data is pi over 2? 1 plus sine pi over 2. What's sine pi over 2? 1 plus 1 2. Okay, that's 2. Okay, good job. Okay, that's easy. Okay, the next one here is, oh, remember we have horizontal tangent when the numerator equals 0 and that denominator does not equal 0, right? When does it happen? When it is power 2, right? Then, and also, well, also 7 pi over 6, okay? And also 11 pi over 6 at this 3. How come I exclude this? What happened when data equals 3 pi over 2? Yeah, the top and bottom both equal to 0, right? And then you have to be a little bit careful when both of them equal to 0. Then you have to actually think more carefully later on. Let's set that aside and think about that later, okay? So there's 2, this one and this one, both the numerator and denominator equal 0. So we have to put that aside and think about that later, okay? Now I'm going to just consider this, and this. The numerator equals 0. So pi over 2, 7 pi over 6. 7 pi over 6. And 11 pi over 6. Can you guys figure out the R here and R here? 1/2? I heard you say 1/2, right? Yeah. It is sine of. It is 1 plus sine of 7 pi over 6. Now 7 pi over 6 is negative 1/2. 1 plus 1/2 is 1/2. Yes, it is 1/2. You got it right. And then the other one is also 1/2, right? Yeah, good job. Okay, so those are the, what are those? Those are the horizontal, right? Horizontal tangent at this 3 point, right? Okay, good. Now we're going to talk about vertical tangent. So vertical tangent, what happened when the denominator equals 0, right? This 2. Okay, and the numerator does not equal 0. Okay, so let's put them in. So data will be pi over 6 and 5 pi over 6. Can you substitute data equal pi over 6 in here to figure out R? What does R equal to? 3 over 2? Okay, good job. Okay, so that is 3 over 2. And then what? What, this one? 3 over 2 again. Good job. Okay. All right. Now we're going to tackle this one that is a little bit more complicated, the 3 pi over 2, because both the numerator and denominator equal 0. Okay. Then what happened here is, okay, let me just circle this. Okay. Both of them equal 0. Then you have to be careful. Okay, be careful, and you have to use L'Hopital's rule. Okay, so then you take the limit of this, the limit of dy dx, when data approaching to 3 pi over 2 from the left and from the right. Okay. So I'm not going to test you this on the exam because it's a little bit challenging, but it's good to know. Okay. Maybe for some part of homework, you might have this. So when data approaching 3 pi over 2 from the left here, then you take the limit of that, of dy dx, okay? We know that dy dx is equal to this times this. You break it into 2 parts right here. This one times that, So you break it into limit of this times the limit of this. Well, why do I want to do this? Because what happened? Because what happened when data is approaching to 3 power 2, to this? What sign of 3 power 2? Sign of 3 power 2 is -1. So you get 1 minus 2, which is -1 on top, right? Okay, so this one over here, then you will get -1 on top, and then 1 minus 2 times -1, which is what? 3. Yeah, 1 minus 2 times -1 is the same as 1 plus 2, right? So you will get 3. So this, you get -1 over 3. And then you will get this, right? -1/3. What about this one? What's cosine of 3 power 2? Yeah, you will get 0. Yeah, you got it. So you get 0. Okay, this one. And then what about the denominator? You also get 0. When you have limit of this type, right? 0 over 0, it is what? Indeterminate. Yeah, you can remember. Okay, tell your next teacher. I'm your teacher. Okay, indeterminate form. Okay, indeterminate form. Okay, did I spell this right? Okay, good. Okay, so indeterminate form. So you use what kind of rule? Nobita's rule. It's one of the 2 emergency type, right? So use Nobita's rule right here, and then you differentiate cosine data. What's the duality of cosine data? Negative sine data, and the duality of sine data is cosine data, right? And what's sine over cosine? Tangent. So this is negative tangent data. And I draw the graph for tangent data here, okay? So this is the graph for tangent data. And 3 power 2 over here, you're approaching that from the left. So let's look at the left side of 3 power 2. This is 3 power 2 here, approaching from the left. So it's like this. It's going up and up, right? So it goes to positive infinity. So I'm sorry, it's going to positive. Oh, tangent data go to positive infinity, right? So let's see. Tangent data goes to positive infinity. The negative tangent data go to a negative infinity. And then because the negative sign over here, negative times negative is positive. So it goes to positive infinity. It seems like go negative infinity and positive, and then I'll go back to positive, right? So just remember, negative times negative positive. So this go to infinity, then this things here go to infinity. So that's why infinity. Okay, and so what happened when the slope go to infinity? What does it mean? What kind of tangent? Slope, infinity. What happened when you have an infinity slope? It's a vertical asymptote, right? It's a vertical asymptote. So you will have a vertical asymptote. Okay, and by symmetry, the other side here is negative infinity. So you have a vertical asymptote, not vertical asymptote. It's right now we're having dy dx, right? So the slope is going to infinity. That means you have a vertical tangent. Okay, a vertical tangent, and by symmetry of this. Now it's good to take a look at the picture. Okay, so what happened when you have? It's right here. What was the angle? Is it 3 pi over 2? Okay. 3 pi over 2 should be here. This one right here. Okay. What kind of tangent do we get? We will have a vertical tangent. We have a vertical tangent over here. Kind of it's a little bit tricky. This is very tricky, right? Okay. And horizontal tangent where? Do you see horizontal tangent? Is it here, right? Where else? Here and here, right? We found them. And then vertical tangent where? Here and also here, right? So I think the tricky part is this one. So it's very hard to, sometimes it's a little bit hard to find this, okay? That's one. Okay. All right, and here they have some note over here. They say you don't have to remember the formula for dy dx. You can sometimes just maybe express x and y in terms of this, using this to express in terms of data, and then you can find dy dx. Okay, so that's another way to do it. Okay. Okay, now go to the last part over here. This last example here, we're going to investigate the family of polar curve given by r equal to 1 plus c sine theta. Do you guys see a pattern? So this is r equal to 1 plus c. I'm going to write this. 1 plus c. And what is the c? The c here times sine theta. So depends what the c here is. So the first one here is c is equal to 2.5. Okay. Then the graph is going to be like this. Okay. Does it look like a snail to you? Yeah, it's because the shape looks like a snail. Then they give a name in French. Okay, what's it called? They call, anybody speak French?
Limaçon.
Limaçon. Okay, everybody say limaçon. Okay, so it looked like a cell eye here. Okay, it looked like this. It has an inner loop. Okay, now when C is 1.7, okay, here it is 1.7. What do you see here? It looks like the snail gets smaller, right? The snail shrink, but it still has this inner loop. And what happened when C equal to 1? There's no inner loop anymore, right? It looks like a heart now, okay? Okay, so now what happens when C is 0.7? It goes down, move down, right? It looks like it's like a dimple, right? It's like a dimple, kind of like a peach, right? Upside down. Okay, so a dimple like this, and then it's 0.5. And what does it look like to you now? More and more like a circle, right? More go toward a circle, right? Okay, and what about it was 0.2? Even closer to a circle, right? Okay, so when it's 0, then what happened? It's exactly a circle, right? And then when it's negative 0.2, then you move down, right? It's kind of like this one. It's kind of like this one, except it's go the other way, go down the x direction, the y direction, down there, right? Go down. And if it's negative 0.5, and then it just reverse this, and you get the idea. Okay, so the limaçon, sometimes I would like to maybe animate this, right? The snail like this, and then it's string the inner loop and this and this. So you see the pattern, okay? All right, thank you guys for coming, and that's all for today.